Kia ora. Kia ora koutou. My name is Janine Duckworth at the Bioeconomy Sciences Institute, and welcome to Manaaki Whenua, formerly Manaaki Whenua Landcare Research. I'd like to extend a warm welcome to everybody and who has joined us today and for our Biosecurity Bonanza webinar. Our presenter today is Dr. Mandy Barron from the Bioeconomy Science Institute. Mandy will be presenting the forgotten costs of rabbits and economic powers of research. Now, Mandy has 25 years experience as a quantitative ecologist and modeller, studying the impacts of a wide range of pest species, particularly the epidemiology of bovine TB in possums and rabbit population biology. Today, Mandy is going to discuss the research gaps in our knowledge for that ever-present pest, the feral rabbit. Just a few housekeeping things. As with all our webinars, we encourage interaction and questions. And today, this would be via the Q&A function that you can see in the top of your screen, not the chat. This webinar will be recorded and will be shared after the event. At the end of the presentation, we will answer as many of the questions as we can within the time allowance, but all questions will be transcribed and answered and shared post the webinar. I'm pleased now to hand over to Mandy Barron, who will share her research with us. Welcome, Mandy Barron. Barron. Sorry.
Thanks, Janine. Kia ora koutou. Thanks everyone for tuning in. So, feral rabbits. They're a serious economic and environmental pest in New Zealand. It's been estimated that rabbits cost $195 million per annum in lost production costs alone. That's an MPI estimate from 2020. Another recent estimate shows that farmers spend $74 million per year on pest control. That's all pests, but rabbits were among the top 5 pests identified in that report. And then there's a whole pile of environmental impacts. Warren establishment and grazing by rabbits can lead to increased areas of bare ground, subsequent erosion by wind and water, loss of vegetation, loss of topsoil, runoff into waterways, increased weed problems. Also, rabbit populations can support invasive predators, cats and ferrets that feed on the rabbits. Unfortunately, rabbit numbers and their impacts are predicted to rise with climate change. So with climate change, warmer winters will lead to extended grass growing season, so more vegetation, extended breeding periods leading to more rabbits. Now, this vegetation growth over winter is a double whammy because winter is also the best time to apply toxic baits when there's little other food around. So if these control operations are getting delayed or they're done at suboptimal times, this can lead to poor control outcomes and increased rabbits. And this one's a bit speculative, but if there is a drier spring drought, there'll be less juvenile mortality, less drowning in the nest, less coccidiosis disease, and potentially more rabbits as well. Land use change is also thought to impact rabbit numbers, with subdivision of big runs, big stations into smaller lifestyle blocks, leading to piecemeal control efforts. It's also possible that the mooted opening up of stewardship lands will result in more rabbits as grazing favours non-woody vegetation grass growth that's more suitable for rabbits. Genetic resistance to the disease caused by Rabbit Haemorrhagic Disease Virus, RHDV, has been identified in Australia, not yet in New Zealand, but the increasing proportion of juvenile rabbits that we've found with antibodies to RHDV in New Zealand rabbit populations could indicate this growing resistance. Also in Australia, they've found evidence of genetic resistance to 1080 toxin in Southwest Australian populations. So this slide, is a kind of a grab bag of news headlines from the web to illustrate the ongoing and increasing concern about rabbits and their impacts. That's a particularly good one there. So given this concern, what do we need to do to manage rabbits effectively? I would argue that first and foremost, we need a coordinated approach. But we also need to scope the extent of the rabbit problem. Where and at what abundance are they causing problems? This determines the level of investment that is justified. We also need to develop new control strategies, which will require research investment to develop new tools, new methods, and optimize their use. So there's lots of research gaps here. I'm mostly going to focus in on this issue here, scoping the problem, after a quick rant about a lack of coordination. We've had so many reports that have identified that a lack of coordination is the main problem with our approach to rabbit management. Piecemeal control will lead to poor overall control outcomes. Inappropriate use of control tools can also jeopardise future control efforts. Rabbits are a landscape scale problem. This map here is the rabbit proneness map, and the pinky red areas are high or extreme rabbit proneness. You can see that rabbits are widespread. So unless your property is surrounded by rabbit-proof fencing, anything you do will be affected by what your neighbours are doing as well. And there is a role for some sort of stakeholder group, like the old rabbit management coordination group, to do all of these tasks, scoping the problem, identifying research priorities, education, updating standard operating practices, training and certification, and also applying for product registration or applying for biocontrol releases. So yes, scoping the problem, a big need for research in this area. Firstly, we can't track progress or identify trends without adequate monitoring systems. Effective monitoring of wild rabbit populations is critical for guiding control strategies and evaluating their outcomes. Secondly, we need to know the level of investment that is justified. So estimating that relationship between rabbit damage and rabbit density is fundamental to determining the threshold rabbit density above which the economic benefit of control exceeds the cost of control. Lastly, we need to know more about how the system works, though the interplay between rabbit population and disease dynamics, how they respond to perturbation, so we can optimize when and where to apply control tools. Now, given those apocalyptic news headlines I showed earlier on, you would expect that rabbit monitoring shows that rabbit numbers are largely increasing. However, spotlight counts, which are the typical method used by regional councils used to monitor rabbit populations, show a somewhat different story. As an example from the Otago region, excuse the small scale, but you really just need to see the overall trends. You can see at most sites they're kind of low and steady. Occasionally you get these sort of they look like cycles where the rabbit numbers bounce up and down over time. And it's only really 2 sites out of that 18 sites where you can see a very clear increase in rabbit population numbers with time. So why the difference? We suspect it's probably an issue of representativeness, so where those spotlight routes are located. They tend to be, well, they're all located in rural areas. They're long routes, so they're 20 to 25 kilometres. Located in rural areas, yet many of the current rabbit hotspots are in peri-urban areas or rural areas that have been subdivided up for lifestyle blocks, and they can't be surveyed with that spotlight method. Also, some historically problematic rabbit areas, these large runs or stations where most of the routes were originally located, they're actually are now under effective rabbit control thanks to the efforts of their managers, and the Mannaburn site, which is this bottom left one, is a good example of that. But there is obviously a need for a standardized rabbit monitoring method in all areas, including peri-urban areas. And it's not just rabbits that we have to monitor, it's also the caliciviruses that provide biocontrol of the rabbit populations. In New Zealand, we have the pathogenic RHDV1 Czech strain. This was imported into Australia, escaped quarantine there, and then was illegally introduced to New Zealand in 1997. And this strain has a really good mortality rate. It will kill 90% of 90% plus of susceptible rabbits. There's also a benign strain, meaning that it doesn't cause disease in rabbits, but infection with the benign strain does result in antibodies that are cross-protective for the pathogenic strains. And the existence of this benign strain was long suspected, but it wasn't until 2017 that Leila Nicholson, for her PhD, sequenced it from feral rabbit populations. She also found that more than 50% of the wild rabbits in New Zealand are positive for these antibodies, these benign antibodies, and that the RCV-NZ strain is very closely related to the RCV-A1 strain from Australia. The time to the most common ancestor is about 1980s, so a fairly recent divergence. There's also another pathogenic strain that was deliberately but legally introduced in autumn 2018, and this strain was identified by Australians as providing high lethality and the ability to overcome the cross-protective antibodies provided by their version of the benign strains. They released it in Australia in 2017. We released it a year later in 2018. And then there's also RHDV2, which is another pathogenic strain, and that just turned up in New Zealand. It was first detected in 2018 when there was increased monitoring for the K5 release. The RHDV2 is quite different from the RHDV2 that Australia has. And the one that we've got has a very wide global distribution, so it's actually difficult to identify the source. And there are three main techniques that can be used to monitor for the presence of RHDV, each with their pros and cons. Firstly, we've got opportunistic testing of liver samples from rabbits that are suspected to have died from the disease. This is a bit hit and miss, as most rabbits will die underground, or their carcasses might be scavenged or decomposed before the liver can be recovered. Another method is monitoring RHDV antibodies in blood samples from shot rabbits, and this method can provide a measure of likely RHDV exposure of the population, and also an indicator of the potential vulnerability to infection, to future infection. And this method also has the advantage that it can be used to assess the prevalence of antibodies to benign calicivirus. Unfortunately, though, antibody assays for RHDV are no longer offered commercially in New Zealand, and there are methods available and reagents available overseas that can discriminate between RHDV1 and RHDV2, and we could import them here as a research tool. Thirdly, RHDV strain discrimination can be done using PCR-based assays of fly samples, and that's a new technique available in New Zealand that some of the regional councils are using. Carrion flies feed on dead rabbits, and they can vector the RHDV, the virus, spreading it across the landscape. So by sampling flies, well, actually their poo and vomit, we can determine if RHDV is present and circulating at the time of sampling. And we can also identify which RHDV strain is dominant and likely to be having the greatest impact. So what happened to the K5 strain that was deliberately introduced in 2018? Well, as I mentioned before, it was released around the same time that RHDV2 showed up. K5 was selected by the Australians because their lab trials showed that it was able to partly overcome the cross-protective effective antibodies for the benign strain. So you can see here that with the original Czech strain, 50% of the rabbits were surviving if they'd been previously exposed to RCV-A1. but that was reduced to 25% survival when they tried out the new K5 strain. However, when Janine ran similar trials in New Zealand using rabbits that had previously been exposed to the New Zealand benign strain, she got 100% survival, much more survival than those exposed to the original Czech strain, which sat around 57%, similar to what the Aussies found. So, yeah, the New Zealand benign RCV strain provided partial cross protection against RHDV Czech, which was expected, but unexpectedly was completely protective against RHDV1 K5. So that result was a bit unexpected, and that seemed to be borne out by the monitoring at the K5 release sites where the rabbit population reductions were greatest, where the antibody levels were the lowest. And we think that now K5 has been excluded by the other strains, and this is supported by some multi-strain modelling that Cecilia Latham has done, and also by the general absence of K5 in recent monitoring. However, it still has a potential to be used as a biocide, so that's where you release the virus in a specific location, hoping to instigate an epidemic, but you don't expect it to persist and spread. It's kind of just like using it as a toxin. As to what's happening with RHDV2, we don't really know. Limited monitoring from fly traps shows it is the most prevalent strain in circulation. The blue bars here are RHDV2, grey is no disease, yellow is the RHDV1 strains, or yellow and orange. Occasionally you'll detect both RHDV1 and RHDV2 in samples. That's the green blocks there. This figure sort of indicates that RHDV2 seems to be most prevalent in spring, summer, not so much in autumn, which we think is due to it being able to infect very young rabbits, less than 10 weeks of age, which RHDV1 can't do. And RHDV1 tended to outbreak in autumn when the new recruits, those young rabbits born spring, summer, were aging out of their resistant age class and becoming susceptible to infection. The other point of difference with RHDV2 is that it has a much lower and highly variable fatality rate, so 5 to 70%. That's from overseas studies of RHDV2 versus the 90% mortality rate provided by RHDV1. Taken together, that infection of young rabbits in spring and also the low mortality rates, we are concerned that RHDV2 won't provide as good a control as RHDV1 did. And it could also be immunising those young rabbits so that RHDV1 epidemics don't take place in autumn, don't provide control in autumn. Because we know so little about what's happening out there, this is also a plea for study sites with historically high rabbit numbers and suspected disease to see how to optimise our fly trap sampling regime. And my contact details are on the last slide if you've got some leads for us there. And so I think biocontrol of rabbits will have to be part of any integrated pest management strategy, but I think we need to lower our expectations about RHDV and rabbit suppression. We will never get those massive rabbit reductions seen with that first epidemic wave where you were getting 67–80% population reductions. That was a novel virus in a susceptible population. Now we've got 4 strains in circulation. The virus needs rabbits to persist and spread, so biocontrol is all about suppression, not elimination. On the other hand, the virus does persist, it's self-disseminating, and it has manageable non-target effects. So it's probably the safest and most cost-effective tool we have, maybe even the only tool we have for peri-urban areas where it's impossible to use toxins and shooting as a control methods. The Australians have recently estimated that investment in a rabbit biocontrol research program will provide a 2.5 to 36-fold benefit to cost ratio. It is important to note that biocontrol is just one component of an IPM, acknowledging that additional control methods need to be used and coordinated, and that ongoing monitoring and evaluation of control outcomes is key. Shout out to Dean Anderson's talk Thursday, I think, talking about adaptive management. And the other point to make is that we need to make it legal to use RHDV as a biocide, as a biocontrol tool. Currently, the registrations of the two previously available commercial products, RHDV1 Check and K5, they've lapsed. They could be re-registered and imported from Australia for use as biocontrol. But the deliberate movement of existing wild field RHDV strains within New Zealand is not permitted, as RHDV is classified as an unwanted organism. So a case could be made to Biosecurity New Zealand to consider reclassifying those strains, particularly RHDV1 Check and K5, which they have a effective vaccine registered in New Zealand that could be used to protect domestic rabbits. So in summary, rabbits and their impacts are costing us millions of dollars each year and predicted to increase. The current approach is not working. We need a coordinated approach. We need to measure the scale of the problem to know how much to invest and to track our progress towards goals. RHDV is a key component of an integrated rabbit management program, but we don't really know what's happening out there in that rabbit virus landscape, especially around RHDV2. Thank you.
Thank you, Mandy. So I'd just like to say we now have 8 minutes for answering questions. We would like to ask you to include that in any questions in the Q&A chat that you can see at the top. And I haven't got any questions at now, but if you could pop them in, that would be great. I'll just say that we still have a lot of information that we need to know about RHDV2, and we really have had no serious work done on it since it was identified in 2019. So we look forward to people telling us where they're having outbreaks of RHDV, so we could have a look and see how well we can monitor those outbreaks through using the fly trap data. So we've got some new posts coming through. Okay, so the first question we have is from Peter. Is RHDV limited to hares and rabbits? Are there any other non-target species, Mandy?
It is limited so far as we know to hares and to lagomorphs, hares and rabbits. Yes. Yep.
And that's one of the beauties of this particular biocontrol agent, is its specificity.
Yep.
Jason Smith has asked, has there any work been done looking into controlled genetic modifications of rabbits being looked into, like the modification of mosquitoes in Singapore to essentially prevent population growth? Would you like me to answer that one, Mandy?
Yeah, actually, yeah, no, you answer. I know that Australia have looked at proof of concept, but that's as far as I've got, but you will probably have a better idea.
There is an active program looking at controlling the genetics, and big breakthrough has been as up till now the virus has only been able to grow in live animals, and recently they've been able to grow it in tissue culture, which allows them to look at a whole lot more strains. So but that program is very recent, and so it's a kind of a watch this space for what's happening in the CSIRO in Australia.
But that's the virus, Janine, not
yes
the rabbits.
Not the rabbits, sorry.
Yep.
No,
yep.
I have not seen any work where the rabbits themselves are being modified. But it's only been the biocontrol agent. And they've been continued to look for other biocontrol agents, but nothing exceptionally promising has turned up on the horizon as yet.
Yep.
Francis Schmeiko asked, are there any humaneness considerations for or testing for any of the control are there any humaneness considerations or testing for any of the controlled methods internationally or here in New Zealand? Seems another good organisation for coordinated control. When I looked into control options for rabbits some years ago, some of the other options were quite inhumane.
And Australian, they'll have a website of control tools for rabbits, and they actually have a link to a humaneness ranking for the different tools as well. So that will be somewhere to first look for it. But
and RHDV was chosen as its initial one in the 1980s because as a replacement for myxomatosis, which has a much longer time from symptoms to death, whereas RHDV has a relatively very short time from animals showing their first symptoms to death. So it is considered on a more humane version than, say, anticoagulant toxins as well. So RHDV 1. And I'm just loading some more posts. How effective is an RHDV virus strain as a biocide compared to 1080?
It depends how susceptible that rabbit population is. If it's had prior exposure to either the benign strain or another pathogenic strain, then it won't be as effective. Yeah. But if they were completely naive, you could expect to get 95% kills, but that's if they've got no existing immunity.
And I believe it's been effectively used in some island situations for that very reason. Bruce asks, are there any wild strains that are likely to be more lethal of I think he's RHD. Are there any wild strains of RHDV that could be more lethal than others, and could they be identified and potentially used? Yes, there probably are, and we were looking at some higher pathogenic strains, naturally occurring ones in 2012, but then the work got over, the discovery of RHDV1 K5 kind of overcame that work, and the RHDV5 K5 work became a priority. We haven't been assessing it lately, but we have in the past, and some of the strains did become more lethal of the Czech field strain back in 2012.
And that's something that the Australians can do with their tissue culture is trial out these different strains and to assess their lethality. Yeah.
So Chris asks, is there any research being done on the RHDV1 variants from around the country? Not at this time, but as I said, it could be done. Catherine O'Toole asks, have you done any fly trapping in the North Island where rabbits are a problem, i.e. in the southern Lake Taupo area? I can answer that. No, not at the moment, Catherine. We have not been doing much in that particular area. We've got 1 minute to go, guys. Under what conditions is the virus to be more effective? You've noted special areas? Have you noted special areas and climate conditions where viruses have more mortality?
No, we don't, because we don't. We're not monitoring mortality in the field, so that is hard to do. In Australia, they've noticed that it does better in drier climates, does less well in sort of more in wetter climates, but that's all we kind of know, really. And it's that interaction between the effects of climate on the rabbit populations when they're breeding, when their density dependent compensation is, and when the disease hits, and how effective it is as well. So basically
quite complex.
We don't know.
Hannah asks what sort of study sites are we looking for? I think we'll be best to take that one offline, Hannah, and describe you that sort of thing and talk to Mandy. And the last question, which I'm going to ask, is from Robin. Robin, would you expect cats and other predators to switch to birds for food when rabbit numbers drop?
I don't know. You do hear anecdotal reports about prey switching, but whether that's been well documented, I'm not sure. No, sorry, I can't answer that one at the moment. Yeah.
Oh, well, thank you very much for everybody who's attended. We've run out of time. We're going to endeavour to provide answers to all your questions in the chat over the next few days. So thank you very much, and thank you very much, Mandy.